So can somebody tell me what the end values of x are? Where does x range from? What's the smallest x can be? Yeah.
For the largest x, I guess would be root a, because if you, I think.
Okay, the claim was that the largest x could be root a because somehow there's this x squared here and you can't get any further past than that. But there's a key feature here of this problem, which is that a is variable. The only thing that's fixed in the problem is v. Okay? So if v is fixed, what do you know about x? Yeah. X is greater than 0. Yeah, the lower end point, that's safe, because that has to do geometrically with the fact that we don't have any boxes with negative dimensions. That would be refused by the post office, definitely, over and above the empty top, which they wouldn't accept either.
X is always less than the square root of v over y.
It's true that x is less than square root of v over y, so that's using this relationship. But notice that y is equal to v over x squared. So 0 to infinity, I just got a guess there over here. That's right. Here's the upper limit. So this is really important to realize. This is most problems. Most problems, the variable, if it doesn't have a limitation, usually just goes out to infinity. And infinity is a very important end for the problem. It's usually an easy end to the problem, too. All right? So there's the possibility that if we push all the way down to x equals 0, we'll get a better box. It would be a very strange box, a little bit like our vanishing enclosure, and maybe an infinitely long box, also a very inconvenient one, might be the best box. We'll have to see. All right? So let's just take a look at what happens. So we're looking at a at 0 plus, right? And that's x squared plus 4v over x with x at 0 plus. So what happens to that? Notice right here, this is going to infinity, all right? So this is infinite. So that turns out to be a bad box. All right, let's take a look at the other end. So this is x squared plus 4v over x, x going to infinity. And again, this term here means that this thing is infinite. So the shape of this thing, I'll draw this tiny little schematic diagram over here. The shape of this thing is like this. All right? And so when we find that one turnaround point, which happened to be at this strange point 2 to the 1/3, sorry, v to the 1/3, that is going to be the minimum. All right? So we've just discovered that it's the minimum, which is just what we were hoping for. This is going to be the optimal box.